Hello friends, I welcome you in lecture number 19 on random variables. In this lecture, we are going to discuss this question on finding mean and variance of random variable. This question was asked in GTU Summer 2021 exam of Applied Mathematics for Electrical Engineering subject. First, we understand what is this question about. Two cards are drawn successively with replacement from a well-shuffled pack of 52 cards. Find the mean and variance of the number of kings. Here experiment is we are drawing two cards one by one from a deck of 52 cards. We are having total 52 cards and we are selecting or drawing two cards one by one. First we select one card out of 52 cards and that is called first draw or first selection, and after drawing that first card we draw another card again from the deck of 52 cards. So that we call as second selection or second draw, and here it is given that they are doing this process with replacement, that is first draw one card out of 52 cards, again put back that card in the deck of 52 cards and then select second row. So this selection of second row will be independent of the selection of first draw because this process is with replacement, and whatever card we select, for that card there are different possibilities. There are 52 possibilities for that selected card. So we have to find out the probability that that card is a king. So our random variable is, if we consider that card as a king, then we have to find out the expected value of this random variable, number of kings in two draws. We are selecting first card. That card can be a king or it cannot be a king. Similarly, we are selecting another card. That card also can be a king or it cannot be a king. So we are having this random variable, number of kings in two draws. So there are possibility that in both the draws no card is a king. So one possible value for number of kings is 0. There can be one first draw can give you a king or second draw can give you a king. So there is this possibility also that number of kings can be 1, and there can be a king in first draw as well as a king in second draw also. So there are three possible values for this random variable, 0, 1 and 2. We are selecting two cards successively one by one. So those two cards can be both king, or only one card can be king, or there is no king out of those two cards which we have selected in two draws. So we are asked to find out expected value of this random variable, number of kings in two draws. We have to find out expected value of this random variable and variance of this random variable x. And we know that to find out expected value of a random variable, we have to first decide the probability mass function of random variable x, and this expected value is defined as sigma x times value of probability mass function at point x over all possible values of x. So here we are not given probability mass function. We have to decide probability mass function of x, and after deciding probability mass function we can find out expected value of x and variance of x. Now by the definition, probability mass function of x is given by p of x equal to probability that capital X can take the value small x. we know that this x equal to x denote the event. It is the set of all possible outcomes in the sample space whose value or whose image under random variable capital X is small x. So we have to decide these probabilities for small x equal to 0, 1 and 2. And for this we will do this for one by one. First we will calculate probability that capital X equal to 0. That means probability that no king is selected in both the draws. Probability of no kings means whatever card we have selected that is not a king in a first draw, non-king in first draw, or card selected in first draw is different from king, and second draw also will give you a card which is not a king or non-king in second draw. Probability of capital X equal to 0, that is probability that there are no kings in both the draws. That means there is no king in first draw and no king in second draw. And you can see here we have AND, that is we have intersection of two events. One event is card selected is not a king in first draw. Second event is card selected is not a king in second draw. And it is given that this experiment is done with replacement, that is whatever card we select in first draw we put that card back in the deck of 52 cards. Therefore the total number of cards for the second row remains 52 also. So the second row is independent of first draw. That means these two events are independent and we are interested in the probability of their intersection, and we know that if two events are independent then probability of their intersection is nothing but product of those two events. That means this probability of non-king in first draw and non-king in second draw will be equal to probability of non-king in first draw times probability of non-king in second draw. Now how to obtain this probability? So we are selecting first card, we are selecting one card in first draw and we are finding the probability that that card is not a king, and we know that total number of cards are 52 and there are 4 kings, so remaining cards are non-king or remaining cards are different from king. So there are 48 possibilities in favor of non-king. So this probability of non-king in first draw is 48 by 52. Similarly, I have to write down the probability of non-king in second draw, and it is given that this is with replacement, that is whatever card we select in first draw we put that card back into the deck of 52 cards. Therefore total number of cards for the second draw are also 52, and we are interested in this card selected as non-king, that is king is not selected. So selected card is not a king, that means selected card can be any card out of 48 because there are 4 kings, and this is the required probability you can find out by simplifying this. Okay, this is 12 and here we have 13. Similarly here also 12 and 13. So 144 divided by 169. So this is the value of probability mass function at small x equal to 0, and it is 144 divided by 169. In this way I have to calculate probability that capital X equal to 1 and probability that capital X equal to 2. Suppose I am interested in the probability that capital X equal to 1, then instead of no king I have to write 1 king. So in the 2 rows I have 1 king. I am selecting first card in the first draw, and I am selecting 2 cards, 1 card in first draw and second card in second draw, and we are interested in the probability that there is 1 king out of those 2 selected cards in 2 draws. So there are 2 possible ways, that either first card is a king and second card is a non-king. Similarly, another possibility is first card is a non-king and second card is a king. So in both the cases we have only 1 king. So, and these 2 cases are disjoint. If this happens, then this cannot happen, and if this happens, then this cannot happen. That means those 2 events are mutually exclusive. So that I have written here, probability that capital X equal to 1 is equal to probability of 1 king in both the draws. So this can happen either in this way, that is king in first draw and non-king in second draw, or non-king in first draw and king in second draw. In both the cases we will obtain 1 king. So we have to consider both the events, the possible events for this event. This event is union of these 2 events. It can occur either in this way or in this way, and both the ways are mutually exclusive. That is, we have this type of situation, probability of A or B, that is probability of A union B, where A is king in first draw and non-king in second draw, and B is non-king in first draw and king in second draw. And we know that if these 2 events are mutually exclusive, probability of their union will be equal to probability of A plus probability of B. Therefore, in the next step I have written that this probability of this event, king in first draw and non-king in second draw, or non-king in first draw and king in first draw, this is equal to addition of this event and this event, that is probability of king in first draw and non-king in second draw plus probability of non-king in first draw and king in second draw. And this we can write because we have mutually exclusive events, this event and this event. These 2 events are mutually exclusive, therefore probability of their union is equal to addition of their probabilities. Now how to obtain probability of this event? Probability of king in first draw and non-king in second draw. So it is clear that because we have this problem with replacement, these 2 events are independent events, therefore probability of their intersection is equal to product of their probabilities. So probability of this event equal to probability of king in first draw. This is equal to probability of king in first draw into probability of non-king in second draw, because these 2 events are independent events. Now what is probability of king in first draw? So there are total 52 cards and there are 4 kings. We can select 1 king out of 4 kings in 4 ways. Similarly, probability of non-king in second row, here also total cards remains 52 and cards which are not king are 48. So this probability will be equal to 4 by 52 into 48 by 52. Similarly, probability of this event is also obtained by using the same logic. These 2 are also independent. Therefore, probability of non-king in first draw and king in second draw will be equal to probability of non-king in first draw times probability of king in second row, which is 4 by 52. So that I have written directly here. This is what I explained for this event using the concept of independent events. Probability of king in first row times probability of non-king in second row, and here probability of non-king in first row and probability of king in second row, and here we are using multiplication law for independent events, and this is 2 times 4 by 52 into 48 by 52. So I multiply by 2, and after simplifying I find that probability that capital X equal to 1 or probability of number of kings is 1 is 24 by 169. That is, value of probability mass function at x equal to 1 is 24 by 169. And last possibility is the selected cards in both the draws are kings. That is, probability that capital X equal to 2. That means probability of 2 kings in both the draws. That means probability of in first draw also we have king. Whatever card we select in first draw is also a king, and whatever card we select in second row is also a king. That is, probability of king in first draw and king in second row, and because we are doing this with replacement, both are independent events, this is equal to multiplication of probability of king in first draw into probability of king in second draw. Probability of king in first draw is, there are 4 kings, 4 by 52, and same thing here also 4 by 52, and we can cancel out 4. Here we have 13, here also we have 13. 13 into 13 is 169. That is, probability of capital X equal to 2 is also obtained using this multiplication law for independent events. Probability of 2 kings, that means king is selected in first row and king is selected in second row because of intersection and independent events. This is equal to probability of king in first row, which is 4 by 52, times probability of king in second row, which is also 4 by 52, and this turns out to be 1 divided by 169. Probability that capital X equal to 2 or probability that there are 2 kings in both the draws is 1 divided by 169, and this is nothing but value of probability mass function at small x equal to 2. So here now we have obtained value of probability mass function at all the possible values of random variable capital X, which are 0, 1 and 2. Value of probability mass function at 0 is 144 by 169. Value of probability mass function at 1 is 24 by 169, and value of PMF at 2 is 1 divided by 169. And once we have values of probability mass function, we can find out expected value of random variable x, which is given by sigma x times value of probability mass function at point x. Here possible values of x are 0, 1 and 2. So we now find out mean of x. Mean of x is given by expected value of x equal to sigma x px, x equal to 0 to 2. For x equal to 0, we have 0 times p of 0, then plus 1 times value of PMF at 1 plus 2 times value of PMF at 2. This is 0 into value of PMF at 0, 144 by 169. So we substitute these 3 values here. 1 into value of PMF at 1, 2 into value of PMF at 2, and this is going to be 0. Here we can take 169 LCM. Here I have 24 plus 2, that is 26 by 169, and we can cancel out 13. So I have 2 here and 13. that means expected value of x is 2 divided by 13, and we have to decide variance of x also, and we use this formula for variance. It is given by expected value of x square times square of expected value of x. We have obtained expected value of x, which is 2 by 13. So for variance, first I have to calculate expected value of x square. So that is also given by this formula. Expected value of x square is sigma x square times value of PMF at x equal to 0 to 2. So for x equal to 0, I have 0 square into P of 0. For x equal to 1, I have 1 square into P of 1. For x equal to 2, I have 2 square into P of 2. And we have all these values now, so that we substitute here, and this is 0 square into P of 0, that is 0, 1 square into P of 1, which is 24 by 169, 2 square, which is 4 into P of 2 is 169, then 169 LCM. Here I have 24 plus 4, that is 28 by 169. This is expected value of x square, and now variance of x is given by expected value of x square minus square of expected value of x. This is 28 by 169. Expected value of x is 2 by 13, and we square this, and I have 4 by 169, and finally I obtain variance of x equal to 24 by 169. So sometimes they ask this type of questions also. We just summarize what was given. Here the experiment is selecting 2 cards out of 52 cards, but successively. First select 1 card, that is select 1 card in first draw, and after that select another card in second row, and this is given with replacement. That means these two events will be independent. First draw will give you 1 card, or in first draw you have to select 1 card out of 52 cards. For second row also you have to select 1 card out of 52 cards. So we are selecting 2 cards out of 52 cards, and those 2 cards selected can be any cards out of 52 cards, and they are defining random variable x as number of kings in 2 draws. So because we are selecting 2 cards, there are possibilities that both cards cannot be king. Out of 2 cards there can be only 1 king, or both cards can be king. So possible values of random variable x are 0, 1 and 2, and we are asked to find out mean and variance of this random variable. And by the definition, mean is given by sigma x times value of probability mass function of random variable x. So for that we have to decide probability mass function of x, and it is by definition probability that capital X equal to small x. So here first we have obtained probability of x equal to 0, that is no king in both the draws, then 1 king in both the draws, and 2 kings in both the draws. And for finding these probabilities, we are using the multiplication law of probability. For probability that x equal to 0, that means there are no kings in both the draws. That means card selected in first draw is not a king, and card selected in second draw is also not a king. Probability that capital X equal to 0 is equal to probability of no king in both draws. That means no king or non-king in first draw, that is card selected is not a king in first draw, and non-king in second row, that is card selected is not a king in second row. And because of and because these two events are independent, probability of this intersection of these two events equal to probability product of their probabilities, that is probability of non-king in first row times probability of non-king in second row. And to find out this probability, we are using the definition of probability. We are selecting one card out of 52 cards and we are interested that selected card is a non-king. So there are 48 cards which are not king. So outcomes in favor of this event non-king in first row are 48 by 52. Similarly, outcomes in favor of this event are 48 by 52, and we have obtained probability that capital X equal to 0. Similarly, we have obtained probability of one king using this logic of mutually exclusive and independent events. For one king, we have to keep in mind that this one king in both the draws can happen in two ways. The first card selected is a king or second card selected is a king. So one possibility is first card is a king and second card is a non-king. Another possibility is first card is a non-king and second card is a king, and these two cannot happen at the same time. Therefore, I have written OR. So these two events are mutually exclusive. Therefore, probability of this or this will be equal to addition of their probabilities. And again, these two are independent. So probability of this and this will be equal to product of their probabilities. So be careful. Here we are using so many things. So you must have all the concepts clear in your mind. Otherwise, you cannot do this problem. You must be clear about the definition of probability. You must be clear about mutually exclusive events. You must be familiar with product rule for multiplication law for independent events, and you must be able to decide probability mass function of a random variable x. You must be familiar with these formulas: variance of x, expected value of x, and you must have practiced this type of problems earlier. So many things you must have in your mind before doing this problem. And I have uploaded total 18 lectures of random variable on this playlist of probability and statistics subject. So if you have not watched all those lectures, you first watch all those lectures first and then go for this question. Here we have used so many concepts. So I hope you are able to understand this lecture. Thanks for watching.